Hello, and welcome to the AI Research Roundup. I'm your host, Alex. Today we're diving into some interesting developments in AI research. We'll be looking at a paper titled GPGA Simple and Strong Reinforcement Learning Baseline for Model Reasoning. This paper suggests a way to use reinforcement learning, or RL, to make large language models better at reasoning without needing tons of supervised fine-tuning data. They propose a method called Group Policy Gradient, or GPG, which is a simpler RL approach. It gets rid of some complex parts, like critic models and KL constraints, making the training process easier and apparently more effective, too, according to their experiments. Okay, so figure 1 here really helps visualize what they found. The top part shows how GPG stacks up against other models on math reasoning benchmarks. You can see the GPG bar. It's the darkest blue one, generally reaching higher performance levels across tasks like AIM 24 and Math 500, and achieving the best average score overall. Then, the bottom chart shows GPG also works well for multimodal tasks, things like visual reasoning and geometry reasoning. Again, GPG, which is the darkest bar there, outperforms the other methods shown, including GRPO, across these different areas. It suggests GPG isn't just simpler, but also pretty effective. Okay, so building on that visual evidence from the figure, Table 1 gives us a closer look at the math reasoning performance, specifically using the QN 2.5 Math 7B model. You can see different versions of GPG compared against the baseline model and GRPO. The key takeaway here is the highlighted row, GPG, with that accurate gradient estimation correction, the one with alpha equals B over B minus M. It achieves the best average score, 47.8, beating GRPO's 43.7. This really shows that the specific design choices in GPG, like age, seem to make a difference. Right, so we saw GPG performed well, and Table 2 helps illustrate why the researchers call it simple. This table compares the components used by different reinforcement learning algorithms, PPO, GRPO, TRPO, and our focus, GPG. It looks at whether they use things like value models, reference models, surrogate loss functions, or policy constraints. And, well, the striking part is the GPG row. See all those X marks? It shows GPG doesn't use any of these components, unlike the others. This really highlights its minimalist design, stripping away that complexity. Okay, so GPG's simplicity doesn't seem to hurt its performance. We saw that with math reasoning, and Table 6 here shows it holds for multimodal tasks too, like image perception. This table looks at 4-shot classification results on 4 different fine-grained datasets. You can see the GPG row achieves an average score of 86.0 compared to 81.9 for GRPO. It actually scores higher on all 4 individual datasets as well, like Flower 102 and Cars 196. So this really underlines that GPG performs strongly across different types of tasks. Alright, so GPG seems versatile. We saw it on the 7B math model and multimodal tasks, and now Table 3 looks at its performance on smaller 1.5 billion parameter distilled models, focusing again on math reasoning. You can see the 2 GPG variants listed, GPG RS1 and 3 rupees. Looking at the average column, GPG RS1 hits 55.7. which is better than the OpenRS models shown, which are around 53.1 and 52.0. GPGRS3 is right behind it at 55.5. This suggests, well, that GPG's strength isn't just limited to larger models. It's effective even here. So we saw GPG works well on those smaller distilled models, and Table 4 here brings us back to the larger 7B models, comparing GPG against a range of other math reasoning models. This table shows the zero-shot pass at 1 performance, basically how well the models do on the first try across 5 different math benchmarks. And if you look at the GPG 7B row, It achieves the highest average score, 51.0, which is better than the other models listed like Urus or Oat0. It seems particularly strong on AMY 24 and AMC 23 as well. So this again just reinforces that GPG performs really well on these tough math problems, even compared to several other strong 7B models. Okay, and continuing with that theme of GPG performing well across different kinds of reasoning, Table 5 here zooms in on geometry reasoning specifically. It uses the GEOQA test set. We see the baseline QN model score is about 35.4. When GRPO is applied, that jumps to 47.48. But applying GPG gets it even higher to 50.80. So, yeah, it's another clear win for GPG, showing it's better than GRPO on this geometry task too, reinforcing its strength in multimodal settings. So, yeah, GPG really seems to boost performance across the board, from math problems to geometry, and even on different model sizes. I think the key takeaway here is just how effective this relatively simple reinforcement learning approach is, especially for complex reasoning tasks. It's important work because finding straightforward yet powerful ways to improve reasoning is really crucial for making AI models more capable overall. Well, that's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.